Hello and welcome to my YouTube channel. Today we are going to see how to control the onboard LEDs of the Tiva C board using the user switches and TivaWare library files. In the previous video, I briefed about the Tiva C board and the features of the Tiva C board. Let me just quickly recall some of the important features we are going to use in this video. First of all, we have to know about the switches. So there are two user switches, user switch 1 and user switch 2, and three LEDs which are available on the Tiva C board. In total, we have two switch and three LEDs. Now, if we check the schematic, then we can find that the switch number 1 is connected to PF4, that is port F's fourth pin. Switch number 2 is connected to PF0, port F's 0th pin. PF1 is connected to red LED, PF2 is connected to blue LED, PF3 is connected to green LED. Now, how to configure the Studio. Now to create a new project, we can go to Start and click on New Project. Click on that. Still it is loading device information. It's taking time. This okay. Let me pause the window in that case. No, okay. So the new CCS project window is open. So first of all, we will have to check the target. So TM target means the microcontroller here. So TM4C 123GH6PM is our microcontroller, which is available on the Tiva C board. Now to connect or to generate a connection between the PC and the microcontroller board, we will have to use Stellaris in-circuit debug interface. Select that and then give a name to the project. So LED underscore control underscore using underscore switch, and then select empty project with main and click finish. Now we can see here by default a small program has been created, and we can check the project explorer window and we see lots of files available with including the main.c. Now first of all, to use the features of TivaWare, we have to go to TivaWare folder and add the files. So right click on the project, go to properties. Under the properties, go to include options. Under the include option, click on the add button. Okay, and then go to browse. And if you have installed the TivaWare, then by default the path is under C. You can go to TI and TivaWare C series 2.2.0.295. Select the folder and click on select folder and click OK. So we have, and then apply and close. So we have added the folder. Now to use the library files, we have to add one more file to the project. For that, right click on the project, go to add files, and then go to C project, C, and then go down to TI, TivaWare. Inside that, open the driver lib folder. Open the CCS folder because we are using Code Composer Studio. Double click that. Open the debug window folder and then select the driver lib.lib file. Open that. You have two options here. You can either copy the files or link files. So I will be going with copy file so that the file will be copied to my project folder. Click OK. And you can see here the driver lib.lib file has been added to our project. Now first of all, let us add some standard library files. For that, hash include control space and st control space. We can check standard int.h hash in. So to auto-complete the code, we can use control space. It will auto-complete the code. st standard bool.h. Apart from that, we need the memory map of the microcontroller board. So hash include inc include folder. Inside that we have hardware underscore memory map.h, and then we will include driver lib. Inside that, because we need to provide system control clock to the port F, we need sysctl dot h folder, h file, sorry. Then we will use include driver lib And because we are going to work with GPIO, we have to use gpio.h. Okay, so we have added the important header files to our project. Apart from that, because we are using these two peripherals, sysctl and GPIO, we can use those C files and include them in our project. For that, right click on the project, add files, go back, and here under the driver lib folder, we can see gpio.c and sysctl.c. We will include them in our project. So yes, okay, copy files to the project. So now we have gpio.c, main.c and sysctl.c. Remember, there is one very good feature by which you can know all the functions which are available with this C files. For that, what we can do is, you can go to view and open the outline window. So in outline window, we can see all the important header files and functions which are available with the C files. So let's start the programming. So first of all, we will have to enable the clock for port F. For that, we need sysctl functionality. So let me open the sysctl.c, double click on that. And in the outline window, we have all the functions which are available with the sysctl.c file. Now, we have to use the function called sysctl peripheral enable. And this function, you can see here, it enables a peripheral, and these are the list of peripherals which can be enabled using this function. So copy this function and paste it in our main code. Now to fill the argument, we have to know the peripheral. Go up, and because we are going to use port F, so sysctl peripheral GPIO F. We will copy this and paste it here. So we have enabled the clock for the port F. Now we have to configure the pins of port F as output port, because these pins will be used to connect the LEDs. Okay. So to configure them, we'll have to use the gpio.c file, and in that we have to check which function can configure the pins as an output pin. For that, this function gpio pin type gpio output, this function we will be using, and this function configures the pin for use as gpio output pin. So we will copy this function from here, Control C, and paste it here, Control F. Now we have to know the arguments for port and pins. Okay, for that, you can just open the memory map.h, and here we can see all the proper arguments for port. So port F base, copy this, and inside this function we can paste. So this is the port, and for the pins we can use gpio.h and get the list of pins. Okay. Okay, so gpio.h, and we are interested in 2 pins for the LEDs, and we know LEDs are connected in pin number 1, 2, 3 of port F. So I'm going to use pin number 1. Okay, and paste it here. Copy this whole function and paste here. I can use pin number 2. So this will be activating the pin number 1, that is connected to a red LED, and pin number 2 connected to green LED. no, blue LED, my mistake. Now let me configure the pins of port F as input port. So again we have to check this function, and let us go to GPIO pin type input, copy this function and paste it in our project, semicolon. Again for the port we have to provide the GPIO port F base, and for the pins, of course we know pin for GPIO underscore pin number 4. This is our switch number 1. And for switch 2, remember port F0 is locked. For that we have to unlock the port or pin. So come down and use this function GPIO unlock pin. And what is this function going to do? It unlocks a GPIO pin which had been previously locked. Yes, we have PF0 locked. So we will copy this function, unlock the pin. So here we have to go for GPIO underscore port F base, and then we have GPIO underscore pin number 0. Okay, so this function will unlock the pin, and then we have to make the pin 0 to work as input. So let me make it input. So these two lines are required for pin 0. Okay, that is connected to our switch number 2. Now let me use the function to configure the pull up resistor for the switches. So for the pull up feature to be activated, we have to go to GPIO, go up and pad config set. What this function will do? This function sets the pad configuration of the specified pins. So it requires 4 arguments. Okay, so port, then pin, then strength, and pin type. So port we know port F, pin we know the pin number, and strength, this argument will be filled by one of these options. So GPIO strength 2 milliampere, 4 milliampere. So in general, the GPIO pins of the Tiva C can be configured to work with 2 milliampere, 4 milliampere, 8 milliampere, 6 milliampere, 10 and 12 milliampere. Because we are going to work with LEDs, we don't require too much current. So 2 milliampere current will be sufficient. And then the last argument, which is pin type argument can be filled with one of these options, which is pin type standard, weak pull up, weak pull down, analog, wake high, wake low. So we are interested in pull up, so we'll be using this argument. So let me first copy this function and paste it in our main code. Okay, and then let us fill the argument. So port, we know the port is port F. So GPIO underscore port F underscore base. Then for the pins, we know the pins are 0 and 1 pin. Okay, sorry, 0 and 4. So this is pin 0 basically, my mistake. Pin 0 and pin 4. Yeah, so here for this we will have to configure GPIO underscore pin 0 or GPIO underscore pin number 4. So in these two pins we are going to activate the pull up and with the strength of 2 milliampere current. So let me take the argument 2 milliampere, copy it and paste it in the strength argument. Last is the pin type. Pin type we need weak pull up. So WPU, copy this and we'll paste it here. Weak pull up means the pull up register will be of very high value. Okay. Now we can read the status of the switches and make the LEDs 1 or 0 according to our status. So for that, to read the pin we'll use if. Then if the pin is, let us read the status of the pin here, GPIO pin read. So I will use this function, and what is this function doing? Reads the value present in the specified pins. Okay, and it will return 0 or 1. Okay, so I will copy this function and paste it inside the if function. Okay, so if the GPIO pin read, which pin? Okay, first we have to provide the port F. So GPIO underscore port F base. Okay, port F base. And which pin we are interested to read? Let me first read the pin number 4. So GPIO underscore, wait a second, sorry. Okay, so GPIO, let me make it a bit small. Yeah, so GPIO underscore pin underscore 4, pin number 4, we are interested in pin number 4. If this pin is high, then in that case we want to make the LED red on. Okay, so for that, to make the red LED on, we have to write on the pin. So we'll use this function GPIO write function and paste it here. And again we have to provide the port. So port F, control C, this is the port F. Second argument is the pin. So pin number 1. So GPIO pin 1 and paste it here. And then the value. Value means what value you want to put there. So to make the red LED on, 0x02. Okay, we will have to provide this. Why 02? Let me show you in binary. Okay, so 0b is binary representation. So 0 is 0000. Okay, and for 2 it is 0010. And 1, here you can see PF1. PF1 is the pin which is connected to red LED. Okay, this will make the pin high. And else, if it is not true, then else we can make the LED off. So just copy this code. Okay, and write 0 on the pin. Okay, okay, this will make the LED off. 0. Okay, this will be 0000. So if the status of the pin 4 is high, then the LED will be on. If the status of the pin is low, then it will be off. Okay, and same we can copy this whole function and repeat it for the switch 1. Okay, so copy this and delete. Let me just keep the indentation. Okay, okay, now I have to fill this function. Okay, so now this will be pin number 1. No, pin number 0, because switch is at pin number 0, and we want to make the blue LED on or off. So for that, if this pin is high, we'll make it 0, and here make it 4. Okay, 4 means this pin will become delete 1 0. Okay, my mistake, I made a mistake here, so it will be 0 because it is pulled up by default, and here it will be 2. Because the switches are pulled up, they will be by default high, and when I press the switch, they will become low. So when we press the switch, the pin becomes low, and if it is low, then we will make the LED high, and if it is high, then we'll make the LEDs low. Okay, because this is connected to the 5 volt. So if it is by default 5 volt, in that case the LED will be off, and when we press the switch, this pin will go low, and we will make the LEDs on. This is all about the program, and we have started the while loop here, and okay, so while loop has been closed here. Now let me just check if there is any error in this program. I can just compile it, and it says there are 3 error expected, a semicolon here. Okay, so we have missed the semicolon at the end of this function. Let me recompile and check. So yes, there is a small warning that statement return 0 is unreachable. We can just comment it. It is unreachable because the program will always stay in this while loop. So return 0 will never occur in this program. So this is our program, and let me just upload the code to the microcontroller board. Okay, for that there are 2 options. One is using debug option, second is using flash option. So if you use flash option, then in that case the program will be loaded directly to the microcontroller board, and it will start running. Whereas in debug mode, you can run the code step by step and see all the functionalities of this program and the effect of each code on the microcontroller board. So it is always recommended to use the debug mode in the first iteration. Check if the program is running according to your wish, and if the program runs according to your wish, then you can go and download the flash. Let me just use the debug window, and before that let me just show you the status of my board. For that, let me just connect the camera. Okay, I hope you can see on top right the status of my board. I will use the debug button, click on that, and it will upload the program, and I can debug my program step by step and see the status of each and every line of the code on the board. So here you can see the program has been uploaded, and the program pointer is waiting at this particular position after int main. Let me go step by steps. For that, go up and step into. You can use F5 button to execute the program step by step. Okay, or you can use F6 to step over, so that you can escape the all functionalities of a function. So let me use F6 here. GPIO output configuration, input configuration, configuring the pull up pull down features, and let me read the status of the switch. And since the switch is by default high, the LEDs are off. Okay, let me run the program, and once the program is running, then I can press the switches to see how the program works. Now the program is running in continuous mode. I can just press the switch, so the red LED is on. Leave the switch, press the other switch, and blue LED is not working in this case. So let me just stop the program and see where we made the mistake for the blue LED. So if this GPIO pin should be 2, I believe should be 2, number 2. Yes. Okay, let me recompile it. Okay, so the red LED is blink on and blue LED is also getting on. When I press the switch, the blue LED goes on. When I press the switch, other switch, the red LED goes on. So this way we can program the switches and LEDs to work according to our requirement. Now, with this, I would like to end this video. If you have any doubt or if you have any suggestions, then please put your doubts or suggestions in the comment section. If you have not subscribed the channel, then I would request you to please subscribe the channel, and thank you very much.